Hey everybody, Christopher Black here, Senior Solutions Engineer with Harness. And in today's video, we're going to talk about applying security, applying governance, applying shift-left principles to infrastructure as code automation. So let's jump right in. I've spent much of my career in security, in operations, in DevSecOps, and I've had the privilege really, of working with many of the world's leading technology companies. This is a space I'm very, very passionate about, and this is a use case in particular I'm very, very passionate about. So we have a pipeline up here. And in this pipeline, we're automating the application of infrastructure. So think CI/CD, right? This is something we're all hopefully very familiar with, building, testing, deploying applications. We're applying a lot of those principles to the application of infrastructure. So we have a pipeline. And in this pipeline, we see our Terraform primitives: plan, approve, apply. The technologies Terraform, OpenTofu, these are distinct technologies. I might use these terms interchangeably in today's video, but the core concept that I'm talking about today, that I'm communicating to all of you, is applying security to this process. So within this pipeline, there are several ways to think about security, several ways to think about governance. And also, just kind of as a reminder to everybody, a little bit of context here, these pipelines without governance, without security, are very much the Wild West. I mean, let's just close our eyes, use our mind's eye. Ungoverned pipelines are a thing. They're very, very dangerous in organizations. Let's call a spade a spade. Reason being, if you don't have the ability to apply governance in this process right here, developers, operators, individuals can make deleterious changes to infrastructure without there being any kind of audit log, any kind of mechanism to automatically remediate said changes, etc. So just think for a second, ungoverned pipelines, the blast radius, the potential impact of ungoverned pipelines, ungoverned IaC pipelines is absolutely wild. There's another use case I want to encourage all of you to think about, just to kind of set the tone for the rest of the conversation. Let's also say, even in the absence of infrastructure as code automation, let's say somebody, either through an API, let's say somebody through a management console, let's say somebody modifies infrastructure. They modify infrastructure. They modify the configuration of infrastructure. And let's say they introduce a misconfiguration. Or let's say worse, they introduce a security vulnerability. Okay. Well, in that scenario, there's no context. There's no auditability. There's no information on the provenance of said misconfiguration, of said vulnerability. Are you all with me so far? That's typically where CSPM tools come in, right? Let's just think security for a second. A CSPM tool will say, hey, Mrs. Developer, Mr. Developer, you have a non-compliant resource somewhere in the periphery, but it doesn't say anything about how that non-compliant resource was introduced into your cloud estate. Okay. When we apply security to infrastructure as code automation, now we're using automation to prevent misconfiguration from being introduced into our environment. Now with automation, we have controls in place that prevent security vulnerabilities from being introduced from the perspective of IaC automation. Okay, so that's the context. So let's dive in a little bit further. So within this pipeline up here, I have this step called Checkov. If you're not using Checkov today, pause the video, stop, tap a couple of folks on the shoulder. I certainly encourage everybody to use Checkov. It's an amazing tool. It's an open source tool. We can add it within our pipeline simply by adding the Checkov step itself. There's a handful of configuration parameters. The one I really want to just overemphasize right now, fail on severity. So when Checkov runs, it's going to generate a vulnerability report. It's going to scan your Terraform modules. It's going to look at the code itself, and it's going to say, are there any vulnerabilities in here? Are there any misconfigurations in here? Those findings will be categorized: critical severity, high severity, etc. What a lot of organizations will do from the perspective of DevSecOps is they will fail the pipeline programmatically based on some kind of predetermined threshold. Fail the pipeline every time a critical vulnerability is introduced. Fail the pipeline if 3 high vulnerabilities are introduced. You all get the idea. This is incredibly powerful. These are the tools, if you will, the moving pieces that empower teams, that empower operators to codify true DevSecOps principles. In our pipeline up here, we're not going to fail the pipeline. I have an idea of some of the findings that are going to be generated. We're going to keep on rocking right now. So installing Checkov is very, very, very easy on Harness. I also included TFSec here just to kind of double down on some of the findings. This is certainly overkill. I also have an approval process over here. I'm going to switch to the execution history. I ran this pipeline earlier today. I want to start to close out with. So we have this pipeline, we installed Checkov, we ran a Terraform plan, bang. And then within the vulnerability tab itself, this is what I was talking about. These are all of the findings. These are all of the vulnerabilities. These are all of the misconfigurations associated with our IACM pipeline. And here, it would be categorized based on severity. It's kind of funny. All of our issues today are high severity issues. I'm going to click on one of these at random. Okay, this is a great one. Ensure an IAM role is attached to an EC2 instance. I'm a developer. Okay, seems fairly intuitive. I'm going to click on this, and I'm going to learn more information about the mechanics of the exploit, the mechanics of the vulnerability. Most security scanners, developers will be presented with information from the scanner itself. Okay, great. Better than nothing. Another shameless plug here, folks, but with Harness AI, we are going to dramatically enrich that data. We're going to provide a lot more contextual information. Again, because we have the pipeline configuration, Harness has a lot more metadata about the pipeline, the execution history. So from the perspective of vulnerability management and DevSecOps in the context of infrastructure as code automation, this is money right here, people. This is incredibly powerful information. And let's say for the sake of argument, we had to request an exemption. We wanted to create a JIRA ticket associated with this vulnerability. We could very seamlessly do so. Request an exemption up here, create a ticket down here. And shameless plug, this is new. We tie directly to your respective version control system. So GitHub, Bitbucket, GitLab, doesn't matter. Again, just amplifying that developer feedback loop. Very powerful stuff. Folks, I threw a ton at everybody today. I certainly hope you found this video valuable. Just to recap, we talked about infrastructure as code automation. We talk about applying security to infrastructure as code automation. We talked about how easy it is to set up Checkov, which is a free open source scanner in the context of infrastructure as code automation. Folks, certainly hope you found this video valuable, entertaining if nothing else, and I look forward to seeing you all in the next one. Take care.